Okay, recording started. Hi everyone. Welcome to Cloud Robotics Working Group meeting. We're here today to going to be a bit more loose. We want to eventually make a guide for logging and observability using the cloud. So this is last meeting we discussed a few different guides we could possibly make. We listed I think about 5 things like setting up ML in the cloud and logging and observability. And this was voted the most useful, highest priority by the community. So we're starting with that. There's a blog post if you haven't seen and want to see the other topics on the Cloud Robotics Hub. So yeah, we're not necessarily compiling information today. It's more of a loose conversation. We'll try and figure out what questions we need to answer, what kind of experts we can get in to discuss it, and just see where we get to. So no fixed output needed. So with that, I'll open it up a bit. We have a new guest. I don't know if guest is the right word because there's no membership really to the working group. It's just come along and chat. So a new person. I'll think of a better word. Would you like to introduce yourself, and then we can take the discussion?
So I'm the CTO of a small company, a startup, which is called Botronics, and we develop autonomous golf trolley, basically. So maybe you saw us on LinkedIn because we are quite often on LinkedIn. So yeah, basically that's it. I have a background as a software engineer, but yeah, I'm a robotics engineer. I start as a hobbyist, and now I'm working in my professional career as a robotics engineer. So yeah.
Amazing, thank you. And we've just had Roland join us as well. Roland, would you like to give a brief intro as well?
Sure. My name is Roland O'Flaherty. I work at NVIDIA in the robotics research group. So I am the software engineer in the group, well, manage the software engineering group. And Hugo Hadfield, who I think Michael that you know, joined our group about 6 months ago. And we are more and more getting interested in cloud robotics stuff. We do a lot with these little SO100 guys. I don't know if you can see it here. And yeah, so I wanted to join the group and see what you guys are talking about. Seems like it's relevant with what we're doing right now.
Amazing, great to have you. Yeah, Hugo and I used to work together. Hugo's just joined the group, so that links up. And then the group knew that I had been writing a presentation to give to NVIDIA. I assume that would have been through you, Roland. That happened.
Yeah. You might have talked to Hugo about that. I'm not sure
Yeah.
actually. Okay, I think Hugo's trying to join right now. So yeah, that would be to our group through me and Hugo. He would facilitate it.
All right. Well, we're talking logging and observability. I gave a brief intro before you joined, Roland, but essentially we're just trying to figure out what questions to answer, what experts that we can ask about this to make sure we give the best guide possible, because we're aiming to write a guide about logging and observability in cloud robotics.
Cool.
So with that, I think that's all the intros until Hugo joins, and that's perfect timing.
Perfect.
Until Hugo joins and his window pops up. Hey, Hugo, would you like to give or would you like a chance to fix your camera before I get you to introduce yourself?
Your camera's looking funny.
So, your mic
I
is
could take
also
my
not
camera
selected.
over to Hugo.
Well, let's start discussing. Hugo, when you're good to
Yeah.
go, we'll let you give an intro. Otherwise, yeah. So, topics, questions to our. So, Hugo said I'm a mess. Sorry, guys. Yeah. So yeah, experts in the field, logging and observability, no fixed agenda. So let's. I'm not sure where to start. Let's start with the kind of practical application. I think Anton, you mentioned that might be a good place to set the scene. Why is logging and observability useful, and then we can start to figure out or work backwards from there. Anton, did you hear that?
Yeah, sorry, I missed the question, I think.
You mentioned the practical application that you had. I think we can start with that and maybe work backwards to what kind of logging and observability to capture. But having a practical application does set the context.
Okay. So in the case of an autonomous golf trolley, what's important to say is that you don't have the always connect. Okay, I mean the guy is going on the golf course. He power up the trolley. Maybe there is a Wi-Fi coverage from the clubhouse. Maybe not. Often not. Maybe you have 4G connection or not. So there is this thing. I mean, that's one point. And then when you are during the golf course, you can't say, okay, this trolley is disconnected, so you have an issue or something, because no, the coverage is not an always on, always off. So you need something like, you can't trust the network, basically. You never trust the network, but in this case, by default, you can't trust the network. So you need something to keep the result offline until you are back online and push it online. Okay, so that's basically something. I don't know if you have a specific question around the use case.
What are you using ROSbags, or are you using your own format for storing in the meanwhile on the robot itself?
Oh, that's a good question. In fact, we use ROSbags, but today we can't store everything. That's not possible because we are quite limited in terms of our bill of materials, because it is a B2C product. So you can't have something like, you can't sell your robot at 50,000 euros, right? So that's really, today we have some small bags. We keep some static data, okay? So that's an always on. When the robot is power on, there is this record continuously. And then when we detect something, today it's purely manual. I would say that the user say, okay, there is an issue, okay? And at this time, it starts recording the bags. In addition to it, we made some rolling bags, meaning that when you say, okay, there is an issue, we have the bags recorded previously that is stored as well. Don't know if it's clear. I mean, yeah, the purpose is to be able to reproduce the issue and to see what happens after the issue. So we have this, okay? The issue is not in recording things, but in store things. That's why we made it. And in addition to it, today the way the golfers are powering off the trolley is by removing the battery. So yeah, there is no power off. I mean, yeah, you can't do this. So it's something we have to deal with on our PCB in the end. But today, yeah, there is a turn on, turn off button, but nobody use it. Okay. So it was an issue back in the days with ROSbags, because with ROSbags, if you power off the device, removing the battery, the ROSbag is corrupt. So that's something we had to deal with, and today we did it like using small ROSbags. So if you have an issue with the latest ROSbag, the latest ROSbag unfortunately is corrupt. So that's why you don't keep big time between bags.
So you basically have a script that does this interruption and makes the ROSbags very small every few minutes. Okay.
Yeah, we have a ROSbag manager node, I would say, which consume topics and do all those stuff for us. And so for this, we had to add some throttle node as well, because of course, if you have point cloud and so on, and you try to record it and you are in another process, of course, it creates a lot of issue. So
you brought up a very important thing. I'm not very familiar with the latest ROSbag API or the command line, but there's no throttling in itself, right? You are using an external node. You cannot configure the throttle.
Yeah, but in fact, I think that's quite okay, because I put node, the throttle node, I always put them in a composition to be sure they run in the same process. So the throttle node must not be attached to the ROSbag manager node, but must be attached to the node producing those AV messages.
I find it very interesting because I was just last week at the European project demo, and admittedly a few things didn't go as planned, two of which were too hot, really hot, and the robot was outdoors. And as we were recording Rosbergs, I looked back at I didn't have time to do it yet. We were in the car coming back, so I just quickly looked at the Rosbergs, but I found out that some topics were not recorded with the frequency I was expecting. And I'm guessing either the cameras were also overheating and they stopped sending the topics, or the CPU was throttled itself, and then subscriptions were not just put in the Raspberry. I still have to put my finger on it, but that is something that can happen, and I don't know if any of you have already experienced it too.
And that's something interesting to observe as well. That's the frequency of the topics of the publishers, because you can spot a lot of issues just by looking at frequencies of the published topics.
That's a great point to add on, frequency of published topics. So from what we're just talking about, I think there's an interesting idea, some points of discussion. Format for recording logs. So we've so far discussed Rosbags, but I'm sure there's other formats. And also, are we talking unstructured data, structured? Are we talking log strings? Are we talking JSON messages, etc.? Online, offline logging, something to consider. Automatic incident detection. It sounded like you're doing that. That's when you start recording Rosbags. Is that right?
Yeah, indeed.
Yeah. So we've previously talked about that, and just if you can reliably detect incidents, you could build a company around it. Like, it's not a simple thing to do. And then frequency of topics is in itself a measure of things going wrong.
On that topic, Michael, we also had a call. Remember, we were mentioning building a dashboard, or the existence of dashboards that are exactly showing that, to see whether the system is in nominal state or not. And I don't remember. I didn't remember what it was, but I saw something that does something like that.
I think we did discuss that. We also discussed whether you could. Well, sorry. We did discuss dashboards that could turn parts of the robot functionality on and off. I remembered that, and then I remembered it had nothing to do with logging and observability. So we could probably just ignore that, even though it's a cool idea. So something that's occurred to me is that we're talking here about data that's useful for debugging incidents rather than live overview. How is the robot fleet doing, that kind of a thing, which is arguably part of observability as well. So we can probably think of other use cases. I mean, we can take the golf trolley as our example to keep thinking of. How many golf trolleys are wandering around, and what's their health like, and how do we measure that? I think they're also useful things to discuss. So yeah, any thoughts on any of what I just said?
Yeah, in fact, maybe we can, there is two different things. There is the proactive way of seeing things. Okay, so it means you observe things, and then you are like, okay, this guy, the battery is going down. So we can say, okay, the battery is going down. You should maybe buy another battery. That's something possible. There is the reactive way as well. So the guy saying, oh, there is an issue with my trolley, or worst, okay, I want to, I have an issue because the robot goes into the water, and you have to say, okay, that's not my fault, or this is my fault, but you have to observe, because people will do it. You know that people will do it, and you have to be sure that you can prove that's not your fault if it's not your fault. And that's two different way of thinking. I mean, because the proactive way, you have to have a global overview of your fleet, while when you are in the reactive way, you can say, okay, there is an issue with this trolley. You already know this trolley. You don't have the same granularity. I mean, okay, you know the trolley, and you can go and dive in it and take rose bags, take anything you want, but that's not the same way of working, in my opinion.
I like proactive versus reactive. I think that's a really good way of putting it. And another question that we can ask is it my fault or not that an event happened? So I'm going to add that to my list I'm building up.
That's the reality when you build a project, of course. Yeah.
How long did you keep your ROS bags on the robot, right? So that's often how you decide on these. I'm sorry, I'm getting a call. I'll ask my question later.
So maybe we can talk about other options for, well, I'm going to say recording logs, but logs aren't the only things. Sorry, data isn't the only things you record. So ROS2 topics, sounds like you're capturing those in ROS bags. How do you handle additional debugging information like logging?
Yeah, that's a good question. For now, for logging, we just we have that's the push way. I would say when the user want to push the logs, he can push the logs basically because we are more in a advanced prototype phase. So, but in the end, yeah, you should retrieve it an automatic way, and we handle it using GCP cloud. But there is no robotic stack in place. I would say we build an API using a cloud function, and then you push the logs using this API. Using I mean, you don't push the logs directly using this API because that's not the purpose of this API, but you create a link to a bucket and then you can push the logs because that's blob things. So that's the way to handle it. That's the recommended way to handle it. But yeah, there is no typical way to handle it.
So that on observability and log ingest and stuff, obviously there's a lot of technology out there. Like Prometheus, Grafana, ClickHouse, HyperDX, whatever else. But then also on the transport side, how do you for getting the logs off the robot, do you use anything like MQTT or do you send it over HTTP?
We don't use MQTT today. We thought about it, but for now we don't have a concrete use case to use MQTT. I talk with guys in Belgium working on, I don't know if you have already seen it, that's alco test. Like you can try, to be positive or not to alcohol. I mean, you test it. And on those platforms, they use, that's a big robot if you think about it. But and they use MQTT to retrieve data and to push data. They use it based on AWS. But yeah, today I don't have any use case to use MQTT, to be honest.
But it's also because you're publishing. You said you're publishing the log manually, so pushed on demand or pushed by the customer in the end, and also the ROS bags. I imagine you just push them at discrete points in time. I think MQTT is more used when you're continuously streaming low amount of data. So that's a scenario you're not yet using, right?
Yeah, but I mean that's file that I need to push. I mean that's MQTT is more for small amounts of data. You will not publish a ROS bag on MQTT, right? So yeah.
No, more diagnostics or more the fleet management part you were talking about before with the big picture. That's a typical scenario for MQTT.
Yeah, to handle those kind of things, because I thought about it, but I don't have a monitoring platform in place like Grafana and so on. But to handle it, I was thinking about the TIG stack, so using Telegraph, InfluxDB, and Grafana. I saw that ROS Diagnostics released something around it. So they released something to connect directly to Telegraph or to InfluxDB, your diagnostics topic. So that was something I was thinking about. I don't know what you think about this kind of stack.
Yeah, there's so many different ways to slice and dice it, right? Like with transitive, obviously we're constantly, synchronizing live data, and there we even build a layer on top of MQTT so that we actually get data synchronization as opposed to just message passing. But the application is slightly different. It's really much more for like live viewing, and the health monitoring is a good example, right? Like you have a big fleet publishing into a, in our case, like broker, and then there's different people watching on the web, and some want to see this robot, some want to see the subsection of robots, some want to see the entire fleet. And that's where MQTT is really nice, because it's really just a different, sort of a PubSub architecture, right? But then with the synchronization, we don't have to worry about getting to a consistent state. But yeah, it's more of the live application that Michael was mentioning earlier, rather than the log ingest. That's true.
I think if your robots were more often connected, Antoine, then you would probably also like something like that. But since you have all these connections all the time, it makes more sense for you.
Yeah, funnily, at Savio we had that issue, right? But funnily, these live connections are the first thing that you typically want to get out of these things is my robot online, right? And so for that, you actually want something that obviously constantly tries to connect in a low overhead way. And that's actually really nice about MQTT, because it was built for IoT. It's very lightweight in terms of the reconnection logic, and very reliable in that. And so that's actually the sort of null hypothesis almost of MQTT, just seeing which of my robots are online right now.
You use a heartbeat, right? Something like a...
Yeah. Well, there's a heartbeat built into the system. The broker sends a heartbeat, and you can set the frequency, but yeah, you piggyback on that. Mm-hmm.
You can do a last will and testament as well. If I get
disconnected,
do X. So from that conversation, I got publishing protocol. So HTTP versus MQTT versus other. Can MQTT be used for entire ROS bags? Another one is on-demand versus constant logging. What should you just be constantly logging? And then interfacing with observability tools like Prometheus. I think they're all interesting topics. The topics list is growing.
So on that front, what we're working on right now is we're using that really brand new ClickStack stack. So it's ClickHouse with HyperDX on top of that. And it's compatible with FluentBit and OpenTelemetry. So we are in the process of learning about all of these collectors and shippers and so forth. Antoine, did you guys look into OpenTelemetry, and have you looked at using some of the problems that you described are handled by them, right? Like the retry if you cannot upload successfully, and then also on-device filtering if necessary. Obviously, they are built for the three default things in observability: logs, metrics, and traces. And robotics data is sort of different, because it's kind of too big to fit into any of those categories. But I was wondering whether you guys have looked at them and seen any way to utilize those.
Oh yeah, to be honest, I'm really at the very beginning of this TX stack, so I'm aware of the OpenTelemetry things. I'm not sure, but Telegraph is based on this, no? Isn't it?
Could be. Yeah, I haven't looked at Telegraph yet.
Mm-hmm. Mm-hmm. I think Telegraph is only an implementation of it, using it, but I'm not sure of it. To be honest, I'm really at the very beginning of this TX stack. As I said, it's not yet implemented. It will be in the near future. That's why I'm here as well.
I was just considering the since we are seeing a range, right? We are seeing the Antoine's use case, which is mostly offline. Then when you're online, you sync everything you have. Then Christian has the low bandwidth, heartbeat, I'm alive, talk to me, fleet management kind of thing. And I think there's the next level, which we discussed also a couple of weeks ago, which is something bad is going on, and I'm connecting as a developer to try to debug a remote system, and then I would like more stuff to come through selectively. And that basically covers the whole range, I would say, of the needs that you might have in a remote robot.
So that would be the minimum level of upload, which is the heartbeat, the medium level of only ROS bags when you need them, and the maximum level of I'm a developer, I need everything all at once.
I would like to see what the robot sees. This is also what Christian does, for instance, with WebRTC, but maybe then you want to visualize other stuff, lidars, whatever, and for that you need more, even more penny.
Yeah, the thing that we saw at sort of just to add another dimension to what you were saying, the other thing that we saw at Savio was that depending on the stage of your life cycle, development life cycle, you're interested in constantly logging certain things all the time, right? Or at least having them on the robot. Like, so Antoine was talking about these small back files. You know, after, let's say we are working on a real big navigation stack change, right? Whatever. We want to switch out our our path planner, right? After the release, obviously, we would have been very interested in anything to do with that. We would want to see whether there's regressions, did performance degrade or something like that. And so I think what's really important with all of that log ingest and debugging instrumentation is that you enable your developers to very easily decide what will be logged and what will be the retention on it, really. Like, how long will it be stored on the robot? When will it get thrown away? Potentially triggers, right? Like we talked about that. So for navigation, obviously, you know, if you hit something, or, you know, if there's some sort of emergency stop triggered, those are always good indicators. And just being able to relatively easily modify those things so that the data is there when you need it, because you don't want engineers to spend too much time reproducing issues. So you want to maximize kind of what you can learn from the fleet. So I think that's, you know, as if what Giovanni described wasn't already complicated enough, I think that sort of adds another dimension to what's sometimes needed.
Sorry to interrupt, guys, but I have to sign off for another meeting. But it was great listening in. I'll try to join in future meetings. I think this will be relevant for our work, you guys and I's work here. So hope to participate more in the future.
You'd be welcome. Thanks for coming.
Bye, guys.
Bye.
That interruption might be a good time to allow Hugo to introduce himself as well, if you're all set up now. Nope, never mind. I'll give you another chance to get the mic sorted, but then we'll continue on. Yeah, the head shake of disapproval.
It's not disapproval, it's just indicating, no, I can't hear you.
Oh, okay. For me, it's disapproval. All right. But back to the conversation. Maybe if we hear Hugo suddenly cut in, we can let him introduce himself. Otherwise, so live visualization, further topics, live visualization tools. I think we've discussed previously RViz and how, Foxit? I can't remember the name.
Foxglove.
Foxglove, thank you. Yeah, how Foxglove fills much the same niche. Then levels of data upload, which Giovanni was talking about. Something that we've touched on now with instrumentation, I think is interesting to talk about further, which is exactly what stuff do you instrument? Are you timing at how long chunks of code run, for example? Are you logging, when you log, are you adding extra dimensions like dimensions might be the wrong term, I'm not sure. I've learned Amazon CloudWatch and that's it. And when you log to Amazon CloudWatch, you can enable dimensions, which I understand to mean essentially metadata. You can say this is from software version X, and then when you're looking through your logs, you can specify that and it will filter on those. So that's something that's probably interesting to include in instrumentation. So maybe, Christian, have you looked into that kind of detail in your instrumentation?
I'm not sure I fully understood the question.
So you mentioned that you've been through a process of debugging and instrumentation, and developers need to be able to easily change that kind of a thing. What kind of instrumentation did you put in place? Is the best question.
Yeah. It's funny because in robotics, I feel like a lot of us understand what the problems are, but none of us really understand what really a great solution looks like, because this is sort of how robotics seems to feel sometimes. There's so many things to do. So yes, I described the problem. I come empty-handed on the solution. We didn't have a good solution. I mean, what we we talked a lot about something that apparently Antoine has already implemented, which is the constant recording, right? And then that perhaps dynamically changing the topics that are being recorded. But we actually haven't done that. The only thing that we did do was we used health monitoring, like the ROS diagnostics, very extensively. But that's much more for the live case. It is useful for logging too, right? Because if you then record a back file with ROS diagnostics, then even if there's intermittent issues. So for instance, one of my favorite as in the most annoying issues that we had was our laser scanner was in a bay that had a plastic piece around it, and depending on how you assembled the robot, if you didn't pay attention, the lip of the laser bay was outside of the skin when it should be inside. Well, if it was outside, then depending on how the robot was moving, every once in a while it would sort of dip into the field of the laser scanner. And then every once in a while, the laser would see an obstacle at like 9 centimeters or something like that, right? And that would cause it to stop intermittently. But it was very intermittent. It was very difficult to catch. And so one thing that worked for us was just a health monitor that would constantly log the lowest value of laser, like of obstacles being seen. And then you could record that into a bag, and from that you could see. I mean, it's still a lot of work. Don't get me wrong, and it wasn't nice or easy, but it was. It gave us it killed two birds with one stone, right? We needed the live view on the health monitoring and showed it on our dashboard just for the entire fleet. Is there any robot that has an issue? But then because it is in ROS and you have the recording facility, you could also do some sort of post hoc analysis.
So something that occurred to me from that is custom downsampling, I've labeled it as. So you've got the LiDAR data coming in at 200 hertz. You don't want the entire point cloud, just record the closest reading, but that still gives you a lot of information. I think that does make a lot of sense. And you could extend that to other topics, like instead of recording the full video from a camera, you're doing computer vision, you can just say what classes you detected, which is much smaller data. That's potentially a good way to go.
I think that's a great point, right? I mean, you definitely need to downsample intelligently and all the time, right? Everybody likes to point out how robots produce like gigabytes of data per minute if you actually considered all of the points. And all of them could be relevant, but most of the time they're not. So really deciding what to keep and what to throw away is quite important. And what you want to keep and what you want to throw away keeps changing too. That's why, like you point out, it needs to be relatively easy to change.
Yeah, and just focus on doing this throttling stuff in the same process. That's something, if you don't do that, you will see like performance issue quite fast.
So do you mean in the LiDAR reader node, you should do the downsampling there? And if you don't, then it's a possible performance issue?
Yeah, I think you will have, if you don't sample in other process, because you will have data copy between the processes. And
oh, okay. Assuming that it's not zero copy, which is most of the time true. Yeah, that does make sense.
Mm-hmm.
Yeah, I think this relates also to what Giovanni was describing earlier about some frequencies not being what he was expecting. There was a talk at the ROS by the Bay meetup here, and somebody from NVIDIA actually spoke. Karsten, does that ring a bell, Hugo? Yeah. And he made the point that he basically first started saying everything that he loved about ROS and pointing out that he's a big supporter, and then he spent 40 minutes telling us about everything that's wrong with it, and he made very good points. And one of them was exactly like what you said, Giovanni. Like if the computer can't keep up, then things will just some receivers will just not get their messages, right? And that has a lot to do with how much you put on, right? Like some people think of the LO, like the loopback device, as an infinite bandwidth network connection, but that's not true either. It's not unlimited, right? So yeah, I think that's very important what Antoine says.
Another thought that occurs, this is maybe slightly different, but still on the instrumentation topic, is when I was on Amazon Scout, we were struggling to get everything working on the boards, on the robot. and their solution was to add more boards, which was great fun. Eventually, that turned into maybe we should be trying to measure what's taking all the time and try and optimize some stuff. Yeah, that sounds like a better way to do it. One of the things that some of the engineers were very keen on is applying budgets to different robot areas. So localization should only take so much bandwidth, navigation should only take so much, etc. So for that, we had to start instrumenting code, recording it, playing it back. I don't know if there's a point to this. It's just if anyone had any thoughts based on it, and it does contribute to why we were trying to instrument blocks of code rather than general log messages.
I think it's definitely important. I've heard this from several sides as well. To me, this is it's definitely more of a tangent to what we're discussing here, because you don't log. That's really something that you do on the robot at really high frequency and full frequency basically, and that's more like an S trace, right? Like you really want to get like the lowdown of what's happening on your robot, but only for short periods of whatever, a few minutes, so that you can get a sense and then debug it locally. I think log ingest is much more about sending it up to the cloud, and of course what we're describing here, that would be much too big for upload, and you don't need it in the cloud, right? This is more of a, I guess another way to think about and to break down the problem would be a little bit like the life cycle of the development. It's like on robot and then deployed robots, right? And then large scale monitoring of the deployed fleet. The logging and the log ingest and upload and so forth is clearly more towards the right on that spectrum.
Yeah, that's true. I guess it could still fall under the developer triggers a trace and it's part of observability. So it would be much more.
You could, but then I think you would not upload it to the cloud, right? I think that makes sense from a, something happened. And I would now like to know, what caused it. And so maybe that same trick that Antoine was mentioning earlier, where you can always keep a backlog of the last few minutes. In this case, maybe it's only a few, like 1 or 2 minutes, if you really want to keep the high visibility of what's going on your robot and the budget and how much they used. But I think you would then just keep that on the robot and very, very selectively either debug on the robot or upload it manually. Rather than I think the other question is to keep in mind is who's the receiver. So at CRWG, of course, we realized quickly that we didn't want to have engineers do the debugging of issues in the field all the time, because guess what? Then they don't want to spend any more time doing development because there's so many issues in the field. And so we needed to make tools that would enable non-engineers, and specifically people in our field ops organization, to triage and debug things themselves, or ideally the customer, right? Like if it's as easy as, well, your battery is dead, well, okay, fine. I mean, our robots were self-charging, they should not run out of battery. But if it's something that is somewhat easy to understand by the user, then obviously we want to enable them. But the big thing was to enable field ops people, and that's often where the log ingest and observability came in, whereas developers, yeah, they probably most of the time they wanted a ROS bag. They knew how to get it off the robot, and they would want to visualize it in their own dev setup with Arvis or whatever and dive really deep. But we didn't spend too much time instrumenting that because these engineers already knew how to help themselves.
That's a really important point, Christian, indeed. I wasn't thinking who needs the data, but you're right. Once you have deployed enough robots, it's customer care that has to look at these things rather than the engineers. So then they don't need the ROS bags. They work much more with maybe the feeds from the cameras or something else that they can easily interpret.
And I think that's actually where Foxglove is spot on, right? They enable the big thing there is, you said it, they're like Arvis, but on the web. And well, that's a big difference, because everybody can open a link you can send them. Not everybody knows how to install Linux and then Arvis on it, download a bag file, spin up a ROS core, configure it correctly, and then visualize a short snippet in Arvis, right? So that's why these web tools really helpful to enable more people to look at that data. So I think they're doing a really good job. That also relates to my previous question that I didn't get to ask. When you're recording ROSBAGs, Antoine, are you using actually ROSBAGs or MCAP files?
ROSBAGs for now.
Are you still on ROS1?
No, I'm on ROS2. Yeah.
Okay. Didn't they switch in ROS2 to make the default now to be MCAP?
Maybe wasn't it in Iron? Because I'm still on Humble, and I think it was just the release after Humble, but I'm not sure on this one.
I think you might be right. Yeah, that might.
Yeah. Related to the Foxglove things, it make me think about something else we didn't cover. Is maybe there is one use case we have is that sometimes something work in our office and then we have to test it in a golf course, of course. So we go to the golf course, and when we are on the golf course, everything is offline, okay? So you have nothing but your computer, and you have to observe what your robot sees based on a hotspot, I would say. But that's something that there is an hardware thing here. I mean, how to access data and see things when you are fully offline. Okay, but you are next to the robot, and that's a complex topics because here the bandwidth things comes again. I mean, we had the issue where we were like, okay, when we are on the golf course, we don't run in localhost only, I would say. So you run on the Wi-Fi. You run DDS on the Wi-Fi. Okay, you see what I mean. And then it was complex because the Wi-Fi was clearly saturated, and so you can visualize data. Your robot doesn't behave the way it behaves when it runs local only. So, and you're like, okay, how will I run RVs based on this? And that's the way. That's why I thought about it when you talk about Foxglove. Is that I tried with Foxglove. At this point as well, I was like, okay, Foxglove provide this WebSocket server, so maybe based on this WebSocket, it decreased the bandwidth you need, and so it was one solution. But okay, that's not the solution I took in the end, but that's a solution. But that's what I want to bring here is that it's a complex topic as well. Is okay when you are offline next to your robot, how can you see things?
What sort of data were you trying to visualize?
There was laser scan, video, and so on. But it was because of Wi-Fi dongle as well, because it was a USB device. So of course the bandwidth is limited. But anyway, it is possible to do so based on this dongle. Okay, so that's something we added to the trolley because we were on the field, and so we are like, okay, that's the easiest way to have a hotspot is add the dongle and it works. But it was quite annoying, and we end up using VNC and RVs over VNC.
Yeah.
That's the most elegant solution we found, but I think there is a lot of different solutions.
No, well, so I looked at that quite a bit because we build a WebRTC connector for Foxglove that doesn't use the WebSocket but uses WebRTC, which has a lot of different benefits. One of them, of course, is congestion control. Like, when your bandwidth drops, you can reduce the bitrate of we use it primarily for encoding video, and it's like 200 times more efficient than the WebSocket. And it shouldn't be surprising because the WebSocket, the other issue with the WebSocket is they were sending separate images for video as opposed to video encoding, so you lose out on a lot of optimization. The Arvis, the VNC, or just basically screen sharing, right? Like streaming something that is rendered on the robot using Arvis, that is by far the most efficient way to do this. Point clouds are hard to compress in general, and that's why there are no, for video, H.264 and so forth encoding works pretty well, but to push point clouds, I think it's much better to just visualize it on the robot and then send the video.
Christian, I was wondering if you tried to compare WebRTC with the new. Now I saw that the image transport that is using video compression is also part of ROS2, but I never tried it myself, so I don't know how well it works. Have you ever tried it?
The image, say more.
So there's the image transport that is compressed, which indeed is JPEG for every single image, and then as part of the work of our friends from Berkeley, FogROS2, they actually have implemented an image transport that is using video compression, so H.264 for transmitting images. I think it's H.264, but I'm not sure.
The compression is fine. That's a big step forward. And Foxglove has that now too. They have these compressed image topics, which supports H.264, H.265. That's fine, and that's definitely a big step forward. The other benefit of WebRTC is that it's using UDP, right? That's a different dimension. It's not what's the stream, but it's how do you stream it. And then the other thing in WebRTC is, and WebRTC is not one technology, right? It's a huge bunch of RFCs that have been implemented by browsers to different degrees. But some of those regard this notion of bandwidth estimation. And then what you want to be able to do is dynamically change the bitrate of your encoder. So I don't know whether the image transport does that.
I don't know.
The most straightforward way is obviously you set an encoding and you set a bitrate, and that's it. You don't change it dynamically. If you want to change it dynamically, you clearly need some sort of programmatic control.
You need the feedback, yeah.
Yeah, you need feedback and
congestion control. Yeah.
Do it. But yeah, absolutely going in the right direction.
So I think it's an interesting point. I think we might not want to emphasize it too much because we're straying away from cloud a bit at that point. Direct connections. We have discussed edge in the past. So I mean, you can do things with an edge server and treat it as a cloud server, and you get much the same stuff. But I don't know if you would even claim out in the field that something is an edge server. I do think it's interesting to include. I realize we're running close to time, so I think we've got quite a few topics that are interesting. So now I want to ask the best way to proceed, basically. So next session, I want to start actually compiling information that we can put into a guide. Should we discuss that among the group? Do we know an expert that we can invite and we can start to ruthlessly grill them for this information? Any suggestions?
Maybe I saw something and I tried a platform I saw which is called H-E-E-I-X, which is a French startup, if I remember well. And they provide something to, that's an agent you install on your device, and it records bags, rolling bags, and so on, basically what we do. And they provide the platform behind. So they upload ROS bag and so on for you, and then you can visualize it. I think they have embedded the Foxglove in it. I'm not sure. I tried it quite fast, but that's maybe someone we can ask for. I mean, that's what they try to build. So I give you the name, which is X basically, and I can try to find the.
That sounds really good. Yeah, if they'd be open to joining a session.
Yeah, maybe I can ask them.
There's others too, right? There's also Roboto AI. Did you look at Roboto AI too?
No. Maybe you can send me the link.
Oh yeah.
I'm not sure about this one.
Roboto AI is, at first it looks a little bit like Foxglove, but in talking with Benji, he comes fairly regularly down here. He's based in Seattle, but somehow I bump into him all the time. Their differentiator is they're much more focused on the recording of the storage and the indexing. One thing that even people at Foxglove will tell you, at least in the past they did, I don't know whether that's still current, is that their storage and indexing infrastructure was sort of lagging in the sense that their focus was much more on visualization and they were up, and of course they developed MCAP. We're all very grateful for that, but then the way that they indexed that in the cloud and making it searchable was something that they never worked on all that much. So I think that's where Roboto AI is a little different. They index very carefully, and you can search through tons of data with a query language. Things like, show me all cases where we had a drone that had a Z acceleration over such a limit, and then show me 2 minutes of video around that incident, stuff like that, right? I think that could be very helpful. I'm pretty sure if we invited Benji, he would come and talk to us too.
I think Benji signed up to be a guest speaker at one point, but I don't think we
Didn't
managed.
he? Maybe he already did so too, but maybe I forget the context in which he did it.
I don't think Benji has spoken to us, but yeah, that sounds really good as well. Let's start with Benji, and if he's not able to come, we'll try and contact someone at Heeks, invite them to next session, and give them a.
Yeah.
Sorry, go ahead.
Or both, I'm saying.
Or both. Yeah, why not? I'd thought of it as like a one-person interview, but no reason we can't.
No, not at the same time. I mean, one after another. I'm just, I feel a little. I've told you before. I feel a little self-conscious about us opinionating about things like that when we know that there are people out there that have spent years of their lives developing products around it. So I would feel better if we had heard from quote unquote all of them, or at least try to, so that we don't rehash something that is not even an accurate rehash because there's information that we missed.
Yeah, good point. Okay.
Do you know people at Heeks, Antoine? I think it's a European company, isn't it?
Yeah, I had a presentation back really fast back in the days, so maybe I can find the name and contact him. That's something I can do.
That'd be great. Thank you. So we meet every 2 weeks. So if in 2 weeks or the one after that they'll be available, then that'd be great. We'd be happy to host them. Hopefully we don't double book if we're inviting them in parallel. Okay, so I think we've got a list of topics. When I announce the next meeting, I'll list all the topics from this meeting. So every meeting update I do on the hub says what we did last meeting and what's coming in the next meeting. So in the last meeting we did, I'll list all the topics that we've got there so that we'll have them and everyone can refer to them. Otherwise, hopefully we'll be able to meet again in 2 weeks with hopefully just one expert to interview. And I think that's it. Thank you everyone for coming along, providing your expert opinions. Anything that anyone wants to talk about before we close? And Hugo said, sorry, his mic's not working, but it's been great listening along and some interesting insights. Next time he promises to sort his hardware out. Don't worry. As soon as he said Linux, I was like, yeah, got it. Things are better, but not that much better. All right. Thanks, everyone. See you then. Bye-bye.
See you.